8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply.
There are two objectives in this topic. Now, let's take a look first on the definition of terms that often used in this topic. Remember that satellite cannot be placed into a stable orbit unless two parameters that are uniquely coupled together. The velocity and the orbital height must be simultaneously correct. Launch vehicles may be classified as expandable or reusable launch vehicles. The launch can be divided into two phases. Methods of placing satellite into geo orbit. Orbit classification. There are three useful orbits for communication satellite, which are equatorial orbit, inclined orbit, and a polar orbit. Orbital period. From the table shown, we can see that the orbital period of geosatellites is approximately equal to the period of rotation of Earth around its axis. Satellite orbit also classified based on their height above the Earth, which are LEO, MEO, and GEO. Number 1. Low Earth orbit. Number 2. Medium Earth orbit. third one is geosynchronous orbit, which is known as GEO. Advantages of geosynchronous orbit. A geosatellite distant from Earth gives it a large coverage area, almost a fourth of the Earth's surface, and it has a 24-hour view of a particular area, and it is ideal for satellite broadcast and other multi-point applications.
History of Kepler's law, derived by the German astronomer Johannes Kepler. The first two laws was discovered in the year 1609 and the third law discovered nearly a decade later in 1618, derived based on the analysis of the observation and collected data made by the 16th century Danish astronomer Tycho Brahe. Kepler's first law, also known as the law of ellipses, explained that planets are moving around the Sun in a path described as an ellipse. An ellipse is described as a shape that resembles a flattened circle that can have different values for its width and height. Kepler's second law, also known as the law of equal areas, states that a planet moves in its ellipse so that the line between it and the Sun placed at the focus sweep out equal areas in equal times.
Kepler's third law. Definition of Kepler's third law, the law of harmonies. Kepler's third law stated that the ratio of the squares of the periods to the cubes of their average distances from the Sun is the same for every one of the planets. Amazingly, every planet has the same t² over r³ ratio, which is equal to 1. Ellipse, a standard oval form traced by a point traveling in a plane such that the sum of its distance from the 2 points is constant. Foci, the center of the ellipse. The parameters associated with the Kepler's first law. First, semi-minor axis. Second, eccentricity. Third, semi-major axis. Orbital period. The speed is related to the period in a circular orbit. Larger radius orbit means longer period. A larger semi-major axis also gives a longer period. T² over a³ is equal to constant. The constant is same for all objects orbiting the Sun. Why satellites remain in orbit? Over 23,000 mph, it leaves Earth's gravity. Second, at 17,000 mph, it will go into orbit. Third, if the satellite is lower than 17,000 mph, it will fall back to the Earth. Satellite will remain in orbit because of first, velocity. second gravitational force, third inertial centrifugal force. Basic launching of satellite, Newton's law of motion. Centripetal force is inward force, centrifugal inertial force is outward force. The distance travelled in one orbit around the planet is 2 pi r, where r is the radius of the orbit. A is the semi-major axis of the orbital ellipse. Definitions of terms: apogee, perigee, ascending node, descending node. Line of nodes, inclination angle. Launch vehicle classifications: reusable launch vehicle, expendable launch vehicle. Orbital period. Satellite orbits: geosynchronous orbit, medium Earth orbit, low Earth orbit. Kepler's law. Kepler's first law, also known as the law of ellipses. Kepler's second law, also known as the law of equal areas. Kepler's third law, also known as the law of harmonies.